In this lesson, we're going to cover Unit 6, Standard 1, and our topic is going to be molarity calculations. So first, let's start by discussing what is molarity. Molarity is just another word for concentration. It is the unit used to describe concentration. So when we're talking about how concentrated or dilute a solution is, we're going to use molarity to describe it. The units, you can either express molarity in moles per liter, or we would just write a capital M, and the way this would read is molar. So if I have a 1.0 M solution, it would read 1.0 molar solution. The equation that we're going to use is molarity is going to be equal to moles of solute divided by liters of solution. So you can see that's where the units come from. Moles divided by liters, moles divided by liters. This is really important. The denominator, the volume, must be in liters. Sometimes you will not be given liters, you will be given milliliters. So we have to know that 1 liter is equal to 1,000 milliliters. So if you're given milliliters, you're going to have to convert to liters. Alright, let's start simple. What is the molarity of a 5-liter solution that contains 2 moles of glucose? What is the molarity of a 5-liter solution that contains 2 moles of glucose? So I have my equation. Molarity is equal to moles of solute divided by liters of solution. Well, this solution contains 2 moles of solute, and I have 5 liters of solution. 2 divided by 5 would give me 0.4 molar, capital M. Significant figures are not going away. 5 liters has 1 sig fig. 2 moles also has 1 sig fig. Therefore, my answer can only have 1 sig fig. Alright, let's try another. This time, let's solve for moles. Let's say you were asked to calculate the number of moles of NaCl in 370 milliliters of a 2.50 molar solution. So the first thing that jumps out at me right away is 370 milliliters. But in order to use this equation, volume must be in liters. So the first thing that I'm going to do is a conversion. Remember from last unit, we said we always want to set up the units so they cancel. So if I'm starting with milliliters, milliliters have to go in the denominator. And there are 1,000 milliliters in every 1 liter. So to convert from milliliters to liters, I'm going to divide by 1,000, and I would get 0.37 liters. My equation is molarity is equal to moles per liter. So we want to calculate the number of moles. So now we can rearrange our equation. If I wanted to solve for the number of moles, I need to get liters out of the denominator. I would multiply both sides by liters. Mole is equal to molarity times liter. This is a 2.50 molar solution times 0.37 liters. 2.5 times 0.37, I get 0.925. Let's talk about significant figures. 2.50 has 3 significant figures. A trailing 0 after a decimal is significant. So the 2 is significant, the 5 is significant, the 0 is significant. This number has 3 significant figures. 370 only has 2 significant figures. It also has a trailing 0, but the difference is this trailing 0 comes after a decimal. So if one number has 2 and the other one has 3, how many should my answer have? Well, when multiplying or dividing, the smallest number of significant figures determines the number in your answer. Since 370 only has 2 significant figures, my answer can only have 2 significant figures. So final answer, 0.93 moles. Third example. Now let's solve for liters. Let's say you were asked, how many liters of a 0.75 molar solution can be made from 1.3 moles iron 3 chloride. So again, we're going to use that same equation. molarity is equal to moles per liter. But now, if we're going to rearrange this equation to solve for liters, liters would be equal to moles divided by molarity. So now let's solve. I have 1.3 moles divided by a 0.75 molar solution. Let's take 1.3 divided by 0.75, and I get 1.73 repeating. Last step is significant figures. 1.3 has two significant figures. 0.75 has two significant figures. That means my answer can have two significant figures. The next digit is less than 5, so we're not going to round up. So final answer, how many liters can be made? 1.7 liters.